As you know, this session is titled Breaking the Boundaries of Engineering Education. And firstly, for those of you who joined expecting to see Neeraj Agarwal, my apologies. There was a change in schedule and we had to swap our sessions. And while I can't deliver Neeraj, I will try and get close. Most of us have heard about liberal arts framework as one of the models of imparting education that is more holistic, that combines elements of natural sciences, social sciences, humanities, and really brings context to education. That concept has been around for a number of years or decades and is well accepted, well understood. What we want to explore in this session is really applying the concept of an interdisciplinary approach within engineering education. This is one of the ideas and principles that is core to what we are trying at Plaksha. And hopefully in this session, we can give you a little bit of background by what is meant by it, how does it really manifest itself in the classroom, why is it relevant in the world today, and what are the trade-offs, if any. And I'm really excited to be joined by three very distinguished academicians to talk more about this theme. Pallavi, maybe we can get the videos on. Hi, Arvind. Let me start by introducing Dr. Arvind Raman. Arvind is the Robert V. Adams Professor in Mechanical Engineering at Purdue University. He is also the Executive Associate Dean to the faculty and staff and Professor of Materials Engineering. So clearly wearing many hats already. He is also an alumnus of my alma mater, IIT Delhi, and went on to study masters at Purdue and then got his PhD from UC Berkeley. Thanks, Arvind, and welcome. Dr. Keith Buffinton is a professor of mechanical engineering at Bucknell University and is also the former dean of engineering at Bucknell. Among his many achievements in areas of interest are innovation and entrepreneurship, where he's done a lot of work in how to build that ecosystem in the context of Bucknell. Keith studied at Tufts for his undergraduate and then did his master's and PhD at Stanford. Welcome, Keith.
Thank you.
And we have Dr. Uday Desai, who is the founding director. Sorry, is the Dr. Desai's screen on?
Niten, Dr. Desai is just joining us. He's facing some internet issues. He'll be here.
Okay, so I will maybe just introduce him and hopefully he will join us momentarily. Dr. Desai is the founding director of IIT Hyderabad, with which he was associated until 2019. And at present, he continues to be Professor Emeritus at IIT Hyderabad. He's also an advisor and mentor to several institutions in India and overseas, and has played an integral role in institution building in many of these places. Dr. Desai received his undergraduate degree in electrical engineering at IIT Kanpur and did his master's at the State University of New York, Buffalo, followed by his PhD from the Johns Hopkins University, all in electrical engineering. So welcome to all of you. And to kick off this session, maybe I'll start with you, Arvind, and really ask you to share your interpretation of what is this interdisciplinary approach in engineering education. What does it really mean and how does it come to life?
First of all, good evening, Niten, and thanks to the entire Plaksha team for organizing this Infinity event and this panel. And a hi to Keith and Uday. It's nice to have a chance to be with all of you virtually here. I think interdisciplinarity in the context of engineering education generally speaks to something that we've all known as traditional engineering education. When people graduate from traditional engineering and go to a real life situation, they know that any significant progress that has to be made in any real life engineering, in any real life problem that engineers get engaged in, requires really an interdisciplinary mindset. What that means is you're always typically working in teams, people from very different backgrounds, and not just different kinds of engineering, but you're going to be dealing with people who are in customer service. You're dealing with people in marketing. You're dealing with people with a sociology background, people, teachers, educators. Depends on who the customers are, who the people you're trying to serve with that product. What comes of that team, and I include the beneficiaries when I talk of the team, I include the beneficiaries of the service or product. what ends up happening is the streams of multiple disciplines kind of come together and a common shared understanding emerges on the needs. And there are these interfaces that people start learning a little more and start their positions, their understanding starts changing from what they usually had. It's that shared understanding that comes from people from different disciplines together to solve problems. That is the characteristic of interdisciplinary mindset in engineering. The challenge and the big question is, can you be intentional about getting people ready for that before they go to the workplace? And that's what we're going to be talking about, hopefully, today. Over.
Right. Before we get to that, though, Arvind, maybe I can switch to you, Keith. And welcome, Dr. Desai. We missed you for a few minutes, but we introduced you.
No problem. Thank you. Yeah.
And, to your point, Arvind, this is about sort of getting different mindsets together. And I'm curious, before we talk of some of the issues you raised, if maybe, Keith, you can talk a little bit about, from a student perspective in a classroom, what does it really mean? We've sort of all grown up, at least in our generation, being electrical engineers or computer scientists or mechanical engineers. What does this new world look like in the classroom? Is it very different, or is it more of the same but sort of nuanced on the edges?
Yeah, thank you, Niten. And thank you for having me as part of this panel. I'm looking forward to the conversation and looking forward to the questions from all of the participants. So I would like to echo what Arvind said. I think that interdisciplinarity is the way that engineering is done in the world and in the industrial world in particular. And the question is, how can we prepare students to do that? And to your question, I think there are lots of ways that we can engage students to make sure that they have the experience, at least part of that experience, while they're undergraduates. Here at Bucknell, we're a relatively small school, so building on what Mark Somerville was saying, some of these things scale readily, some of them not so much. We actually have a fair amount in common with Olin. But we try to engage our students as early as possible with the idea that they should be thinking broadly, that engineering is not just a very narrow discipline that they have to somehow master and survive, that really engineering is serving the public good. It's about creating value. It's about thinking about how to learn about a new subject and apply it in new areas. And it's about working in teams and working with others. So we have examples here at Bucknell. As was mentioned before, I'm former dean of engineering, but I am now pretty much 100% back in the classroom. So I teach a freshman seminar where students are focusing on the grand challenges of engineering and the UN Sustainable Development Goals. That in and of itself opens up the students' minds to the fact that there are big problems that aren't just solved by technical expertise. And they, I think, gain a little bit of an awareness or a little bit of a change of perspective on what it means to be an engineer. We try to reinforce that throughout our curricula. We do that in a variety of ways. Design projects seem to be a good way to do that. Working with different constituencies is a good way to do that. And we are an engineering college embedded in a liberal arts institution, so we have a little bit of an advantage in the fact that the students and the faculty that our engineering students are experiencing are actually fairly broad in terms of disciplines and expertise. One of the things that we do that I think is particularly impactful is we provide a capstone experience, a cumulative experience for our students, interdisciplinary senior design experience, where we very intentionally bring students together from different disciplines to work with an industrial sponsor on a real problem. And it's not a problem that's defined by the sponsor and it's like, go figure this out. It's a problem where we don't know how to figure this out. We don't quite know where the value to our company is in this problem, but we want this group of interdisciplinary students from different engineering disciplines, and we also try to bring in some management students as well, to focus on that so that they can get different perspectives on the problem, make sure that they're addressing the problem in a valuable way to the company, and then dive deeply into some of the technical aspects in creating a prototype and testing it and making sure that it really does function in the way that we would like it to, the company would like it to, and adds value. I noticed there was a question as part of Mark's session, which is like, what is the perfect engineer? That's a really tough one to answer, but I think part of what we're trying to achieve is the T-shaped engineer. That's a concept that many of you may have heard before. It's not a new one, but the idea is that you're trying to create an engineer that is T-shaped in terms of their breadth and their expertise. They have deep technical knowledge, probably in a particular area. but they also have the breadth of thinking and the capability of learning new ideas, again, as Mark was saying, that allows them to apply their deep technical skills to broad problems. And I think that's essential in what we're trying to do with our engineers today.
We'll, Keith, come back on this notion of the T. I do want to delve on that a little bit because that's kind of one of the core debates here about breadth versus depth. But before that, maybe I can pull in Dr. Desai as well to maybe share the Indian experience a little bit of, what is happening on this interdisciplinary approach in institutions in India that you may be seeing within the engineering discipline.
Well, what I would say today, it's an in thing. Everybody talks about interdisciplinarity. Nobody will contest that particular concept. And whoever you talk to will say that, yes, I am involved with some form or the other interdisciplinary education. Okay. The issue is at the ground level, how much of it really is there? Sometimes I think, there is subtle difference between interdisciplinarity and multidisciplinarity. Okay. So we do have multidisciplinary education system that is fairly active. Okay. So in some sense, multidisciplinary to me is that, okay, I'm an electrical engineer, I take courses in electrical engineering, and if I like something, I will maybe take courses in humanities or economics or maybe in physics, etc. So to me, that is like multidisciplinarity. But the point is that do we have a curriculum which in some sense integrates different disciplines together? To me, that is interdisciplinarity. One area I can kind of describe where that's how it emerged. In fact, it was born that way, is biomedical engineering. If you look at biomedical engineering, and it was naturally born as an interdisciplinary subject or a program, because there were electrical engineers, there were mechanical engineers, there were material science people, there were people with biology backgrounds coming into picture, there were medical community which were involved. But on the other hand, the traditional disciplines like electrical, mechanical, chemical, to an extent even computer science, though computer science is becoming a little more pervasive because everybody needs some kind of coding, some AI applications, etc. Okay, I think in reality we need to work hard. So my feeling is that to me, if you ask me, and that's why I like the topic of this particular panel discussion, is breaking the engineering barriers. The point is not just breaking barriers. I think we need to essentially break the mold and redesign the whole thing from scratch. Because as long as the mold is still there, what we will do is we'll keep mixing things here and there. Because see, each one, we are human beings, right? I want to protect my territory. Okay, I do not want to lose my identity as an electrical engineer, or within electrical engineering, I don't want to lose my identity as a communication engineer or signal processing person. That's what defined me. That's what the community has given me a lot of credit for. And this happens in every discipline. So I will talk about interdisciplinarity as long as it does not affect my identity. Okay, moment it starts impinging on my identity, I will start sort of, compromising. Not that I will disagree. Okay, so I think something that happened in biomedical is perhaps what is required for the whole engineering discipline by itself, which is easily said, but it's a Herculean task in my opinion.
Arvind or Keith, any of you guys want to take on this theme that Dr. Desai introduced, which is sort of breaking the silos and making it happen, which is as much of a supply side issue from the schools and the faculty and the sort of established tenure as it may be on the student side, and how are places attempting that you've seen do well?
Yeah, I'm happy to add a little bit to that. I think it is difficult. As Mark was saying, it's all about culture, and it's hard to change culture. There's certainly fiefdoms and turf wars that go on between different departments, and it has to do with identity. I think that's very, very true. Part of the change in culture is educating a new generation of engineers so that they are more amenable to the changes that must be made. But I think that's too slow. So the next generation of faculty in engineering that may be in school right now, they're going to be professors in 10 years, and then they're going to last for another 30 or 40 years after that. So we need to be able to somehow accelerate that change. And I think conversations like this certainly help, where we're identifying the issues so that we're bringing them to the surface so we can start talking about them and wrestling with them a little bit and hopefully feeling less threatened to our own identities. But there are also very specific programs. One that Bucknell has engaged in and actually just received some significant funding from the National Science Foundation is revolutionizing engineering departments, RED grants from the National Science Foundation in the US. where the purpose is to really create major cultural change and relatively quickly, and then to disseminate new ideas to other institutions so that they can learn and try those as well. Olin is another, of course, example of this. That's their mission, is to keep reinventing themselves every year and then disseminating the results of their experiments in engineering education to the rest of the world.
One of the things I forgot to mention in Arvind's introduction is that we are also privileged to have him as a member of the advisory board at Plaksha, and he's been integral in the thinking behind the programs. And Pallavi, if we could actually put up the chart which has the 4 undergraduate programs that Plaksha is starting off with next year, that may be an interesting way to sort of start talking about this question of breaking the boundaries. Because interestingly, to the point that Dr. Desai was making, one of the things that is being attempted at Plaksha is really designing, and we have the luxury since we are starting fresh, is to really start with programs that at their core and design itself have multidisciplinarity. So, we're not launching with programs in computer science and civil and mechanical engineering, but these are sort of the 4 majors that are being launched next year as the school starts, which is computer science and AI, robotics and cyber physical, which is electrical, mechanical, autonomous systems. There's the whole biological systems engineering that you were mentioning, Dr. Desai. And then there is a data science, business, and economics theme. Maybe Arvind, since you've been involved with some of this as well, you might want to talk a little bit about, using this opportunity as we are building ground up to try and address some of those challenges and, what the learnings might be given what you've seen.
Yeah, no, glad to. Thanks, Niten. So I think what's exciting about what, Plaksha's vision for learning and teaching is, there's 2 sides to this. One is the curricular piece, which you see here. And what it's going to do is it's going to require faculty from very different disciplines to come and teach major. You can imagine people who'll be teaching robotics and cyber physical systems probably themselves did PhD in 3 different disciplines, at least. In the data science, business, and economics, maybe people who did PhD in 4 different disciplines have to come together, right? So right away, it is forging that common shared understanding, right, which I talked about is really what interdisciplinarity is about amongst the faculty teaching these things. And of course, once you reorganize things like this, there's always the danger that they'll become their own silos, right, in the future. These could become disciplines, long term on their own. So the other thing that Plaksha does is really building this DNA of interdisciplinarity through a vertically integrated hands-on experiential learning, right? So it goes through all 4 years. It is sort of based on Olin's model combined with EPICS, which is the Engineering Projects and Community Service here. That's there all over the world, but we started it here at Purdue, and so have had a chance to learn a lot from past mistakes and how to do it well, etc. And the vertically integrated projects, right? And then we're combining into it what UC Berkeley has been doing with the grand challenges, which is kind of similar to what Keith was talking about at Bucknell, but a focus on grand challenges and SDGs and so on. The idea is that right from year 1 all the way through their final year, they're working in teams that intentionally target these challenge problems. And these challenge problems will require, you have to bring all students from all these disciplines together. You got to bring in beneficiary groups who you're adding value to, who you're creating value for, whether it's industry, whether it's community you're working with, whatever it is. You have to work with sociologists and put the whole thing together, and you're doing it over year after year after year. It is a requirement. It's embedded through hands-on experiential learning. Multidisciplinarity is always going to be a backbone of the Plaksha learning experience. So I'm kind of happy about this two-way approach to it. The curricular piece itself forces faculty from different disciplines to come in together, and then there is this vertically integrated experiential learning, intentionally building an interdisciplinary mindset to solving real-life challenges. Over.
You raise an interesting point, Arvind, which is that one of the challenges in this is to ensure that disciplines like these don't become their own silos over time, that there is truly in the DNA of the place the ability to keep moving the blocks, if you will, as the demands and the requirements of the world keep changing and the grand challenges keep changing. And it's obviously easier said than done, as we all know, because we all like our comfort zones, we all like our kingdoms and turfs. But in some ways, that's sort of the design principle. I want to get back to the point that Keith, you had made about the T-shaped approach. And one of the pushbacks sometimes when you have this discussion around the true ground-up design interdisciplinary approach is the notion of, are you losing on the rigor or the depth that the traditional model has? And I'm curious, and maybe for all of you, how does one create that balance? Particularly when you are approaching it like at Plaksha ground up with these programs that are, by design interdisciplinary. So you're almost starting with orienting towards a world problem or a world situation or a challenge that you're trying to solve.
Yeah, I think that's a great question. I think that's an ongoing debate in some sense. I think different institutions would find the right balance at different points. Mark was talking about that at Olin, and he gets feedback from some of their alumni that maybe they didn't quite get all of whatever bits and pieces of a certain discipline or certain foundation that they might have liked, or maybe they wouldn't have liked it at the time, but maybe if needed at some point in their future. I think the key is that you're really teaching students to learn. If you can embed that fundamental ability in what they're doing and give them enough understanding of the technical aspects as well as broadening aspects, I think they'll be well situated for their future. But there is a reality, and how do you structure a curriculum that allows you to do that? There has to be some fundamentals. You can't give students infinite amounts of work. You can't take an infinite number of courses. So there are, in fact, trade-offs. I think what you try to do is give them certainly the fundamentals. They have to have an awareness, and they have to have skills. They have to have mathematical skills. They have to have science skills. They have to have engineering skills as a foundation for what they're going to do in the future. And they need to have that engineering mindset, I would say, which really takes a while to develop through doing engineering problems and working through technical issues and technical parts of individual disciplines. But I think you also need to give them enough opportunities at least to awaken within their minds the fact that there are other things that T-shaped. So you think of that T as a tree, for example, kind of building on that metaphor. There are the roots in engineering fundamentals that they have to have, but there are also the fruits of other disciplines that are hanging from the tree. So you don't have to show them every piece of fruit on the tree, but you have to make them aware that they're there, and you have to give them enough experience with what those fruits are to be able to see the connections between the roots and the branches and the fruits that are hanging from the tree.
Dr. Desai or Arvind, any thoughts on this? This is an important issue.
So one example, I'd like to say something, if you permit me. I'll come to the T part in a minute. One of the best institute, in my opinion, at higher level, which had what you call multidisciplinarity, was Bell Labs. We are forgetting it because, in fact, if you look at it, I always claim everybody, at least, is carrying a part of Bell Labs with them. Particularly if you have a cell phone, there is no way out of it. And if there's a very interesting thing which I learned. If you look at the speech that Hamming gave, I think it's his retirement speech. And what he said in Bell Labs, what used to happen every day, he would go and sit with different people. So he would go and, he's basically you call an electrical communication person. He would go with guys and have lunch with chemistry folks. Says, okay, you tell me what is an unsolved problem in chemistry. He says, next day I will go and have lunch with the physicist and ask them, hey, tell me what's the unsolved problem in physics. Okay, and I think that is what is required to create that multidisciplinarity. It is not simply structured programs. As a matter of fact, I am not a great fan of structured programs, and particularly today's youth is actually quite averse to structure. And we keep imposing as professors as much structure as we want to. And as a side remark, it is just incidental. We were on a temporary campus when IIT Hyderabad started, and there was a tree out there. Keith talked about a tree, so it was nothing to just because there was no other place to congregate. We had a small kind of a shanty kind of a coffee shop, but every faculty would congregate. Didn't matter whether it was electrical, mechanical, humanities, economics, psychology. Now, when we moved to the permanent campus, after a year, everybody started telling me, Professor Desai, we are missing this. This is where we used to meet and we had really fun interacting. So I think the critical thing, I would say, even for Plaksha, is to make sure that you create this space where you're forced to congregate. Because if you don't, you will have cyber-physical systems where, as an electrical engineer, I will teach something, mechanical will teach something, person in computer science will teach something. It is truly, CPS is truly a multidisciplinarity. But unless you create these spaces, I've seen sort of department buildings. Way back, I went to university in Australia. I'm forgetting the name. Deakin. So Deakin was very proud of a particular department that they were building. There were classrooms had no walls there. Everything was glass. Everybody could see everywhere. Okay. And I mean, I saw this building in some sense. It was kind of being constructed. And later on, I saw the video of it. And then again, I saw something similar at NTU in Singapore. The classrooms were not opaque. They were transparent to everybody walking by as well as the students who were sitting there. Something totally contrary to what we had been doing in the past. Okay. So I think there is some message in it. One should think about it. Now, coming back to T, yes, I think this is a model. In fact, even in my presentation also, I always talk about, breadth and depth. The issue is what compromise we what kind of adjust. This keeps changing. Whatever you do, the students will be happy and unhappy. If you have a lot of breadth and not depth, then they'll complain, sir, this is what and particularly in a system like IIT, which prides itself on depth. Okay, they are not, what do you call it? I went deep into this and really understood it. Okay, so that's their kind of thinking. So this constantly keeps changing. What is breadth and depth? But yes, we need to focus on it. I think right now, I would say a bit of breadth is more important because way the technology is evolving, it is not as disciplinary based. In fact, if you permit me and give me a couple of extra minutes, if you go back to IIT Kanpur, this was designed with a consortium of some 7 or 10 American university involving Caltech, Purdue, Georgia Tech, MIT. MIT was the main champion. Okay. And the program they had, the first such program, I don't know about the US, but certainly in India, science-based engineering. So for a 5-year program, those days, 3 years were common. I mean, I took courses, as a mechanical, I was not great fan of mechanical. I was electrical, so I wanted to get that identity. I took courses in thermodynamics, mechanics, then workshops, lathe machines, the theory of lathe machine, theory of milling machine. Not just this, I took courses in chemical engineering, fluid dynamics, okay, which kind of on the border of chemical and mechanical. In fact, Arvind is at Purdue, the professor who taught me Ramki. I think he probably knows Ramki. Ramki was my teacher who taught me fluid dynamics at Kanpur. Okay. So the point is that, see, they designed it naturally. So at the end of 3rd year, if you ask me, and I could have actually, at the end of 4th, maybe 5th year, I could have actually taught a course in thermo. Of course, later on, I would never do that, but if somebody forced me, I said, okay, in a clutch, because I've learned it, I know about it, I can manage it. And not just me, I would say all of us went through it and nobody complained. So I think we need that. Now that was 1960s. Okay, I think we can't replicate the same thing today. Things have to change dramatically. But yes, this is important, but this requires a major debate. And again, the same length and breadth need not be applied to every institution. Like you talked about Bucknell. Things are a little different. Each one has a different measure. You go to Purdue, Purdue will have a different notion of length and breadth. Okay, I'm pretty sure. See, Purdue is a state university with a large student population. I don't know, it's 30, 40,000 students or something total. Even engineering may be very huge. But if you go to even say Caltech, now Caltech will have a very different length and breadth model because it's a very small group. Okay, I graduated from Hopkins. Hopkins had probably, I think, the total population at that time on campus was 5,000 students. And engineering would be probably 1,500 or maybe less than that. So certainly length and breadth has to be, or breadth and depth has to be very different depending on where you are. I'll stop there. I think I took a lot of your time.
No. Arvind, your thoughts on the issue?
Yeah, Niten. So focusing on this issue of how this actually gets implemented and the trade-offs between, core versus how do you do interdisciplinary sort of stuff. I wanted to maybe it might help providing an example to the audience here of how we do it here at Purdue Engineering. So, we have our traditional disciplines, and then we have a common first-year program, which tries to build a little bit of this interdisciplinary thinking. But really, we are able to build interdisciplinary thinking in through a parallel, vertically integrated stream. So, for example, EPICS is a program. I want to give you an example of engineering programs in community service. So EPICS is a award-winning program. It's won the same prize that Olin Engineering has won, which is the Gordon Prize from the National Academy. EPICS has won it too, and EPICS is now an IEEE program. It's run all around the world, including many institutions in India have EPICS as well. Yeah. Now, what happens in EPICS is, starting from day one, you can, in your first year, start working on a project team. There's a whole variety of projects that are inspired really by community needs, real life projects, and so on. And the vertically integrated projects are those that are inspired by industry, right? But what happens is, when you join that, you're going to be working with senior students who have been working on the same topic over many years. So there's a lot of peer learning that happens here. It's all vertically integrated, right? So when you go up to your second year, then you're teaching students who are just coming in. So a lot of peer learning happens, a variety of projects. I want to give you an example of one such project. This has been running for the last 10 years. It is a series of projects actually with the Indiana School for the Blind and Visually Impaired. Now what happens there is mathematics education. When you use Braille for mathematics education, it's quite a bit of a challenge because right now the main way for visually challenged students to learn mathematics is they use what's called a mechanical brailler, a Perkins brailler. There are some new versions of this that are electronic versions of it, but it's a mechanical device that allows, just like you would take a piece of paper, right? We all will just take a piece of paper and write. That allows us to see what you're doing, make edits. What we do for visually impaired students is they use the Perkins brailler and they can see what they're writing. Oh, this was not right. It's the equivalent of making notes and scratching and stuff. Now, those of you who have been in the classroom and have taught, you know how important it is to observe what the students are working on to really get an insight into what needs to happen. I mean, you can just sit back and see what reports you get and edit them. But wouldn't it be amazing if a sighted teacher of visually impaired students is able to walk by, because all this is happening, the sheet is still in the typewriter, so people can't see what the students are working on. So the thing was, how do you make the relationship between a sighted teacher and a visually impaired student as they're working on math, doing the rough calculations? How do you make it alive so that a teacher can see and go, oh, that's great. Oh, hey, you missed that. Or, oh, that's fantastic. What a great idea. Those things that happen spontaneously in a regular classroom, suddenly in that context, in the life of a visually impaired student, those things are not available. Right, so they worked over years and they set up a beautiful system, which is they have Hall effect sensors. So they integrate, so there's a mechanical integration piece. You take this typewriter, how do you integrate mechanically these sensors? How do you create a sensor display on the back end? And so they've provided this, and they've provided a standard way of doing this that schools around the nation can now use, because these Perkins braillers are being used all over, actually all over the world. But it's a brilliant piece because what it involved is these students, they go and work with these visually impaired students and really understand what is the needs of the teachers, the mathematics teachers. What are the needs? They're in the classroom. They understand the context. They build relationships with the customers. They understand the context. And the teachers involved in it are those who've got mathematics backgrounds, education backgrounds. So you got the disciplines that are informing it. You got the students themselves. The beneficiaries are both. They're involved in it. Students, as you can imagine, have to be mechanical, have to be electrical, have to be computer science. They all sort of come together for this. And over the years, there's this body of shared understanding that's not lost because it's always cycling. Senior students, junior students, they're all coming in together. Industry loves students who have this experience, because they know such students are going to step in, are going to be the people who figure out, hey, that's missing. That's what we don't have on the table. We need to do this to have a better solution. And it's the kind of mindset that Mark was talking about. So we built it through this vertically integrated stream. So we had to force a credit space into a regular education and make sure the students have it as they go through the 4 years of experience. So that's how we tried to build that into what might be a more traditional system. Over.
That's a fascinating example, Arvind. Thanks for sharing that. And I'm just reading some of the comments on the chat. Someone's mentioned that they are part of the EPICS program. So clearly, this is resonating with people here. One of the things as students, maybe this is sort of the last topic we have time for, but just want to touch on it briefly. People are also thinking of outcomes when they go for education and engineering education. And I'm curious, in your experience, as we talk about this interdisciplinarity approach, for people that may be thinking of either jobs in industry or thinking about research and taking something and going really deep or solving a real world problem, or even entrepreneurship, what has your experience been with either employers or financiers or people on the other side as to their excitement or not for such approaches? Maybe we'll start with Keith, since you've done a lot of work around the entrepreneurship theme.
For sure. And I think to your question, I think people in industry and people who are looking for research students and entrepreneurs and innovators, I think there's a commonality of skills. One of the programs that I've been very much involved with is the KEEN program, Current Entrepreneurial Engineering Network, which really tries to instill within universities and then within the engineering students an entrepreneurial mindset, which is not to say they want to be entrepreneurs, that they want to create entrepreneurs. They want to instill within them this idea that you need to always be thinking about how can you add value? What can you contribute to the process, to the product, to whatever that adds value, as opposed to just solving a narrow engineering problem. That came out of the experiences of the founder, Robert Curran, based on his industrial experiences. He found that engineers that he was hiring were often too narrow. They were thinking about how to solve a technical problem and not how to add value to the company. So I think that the response of industry has generally been good. There may be certain industries that just want a commodity engineer who knows how to run finite element programs or knows how to solve certain types of problems. But the ones that are really looking to add value, I think really appreciate what we're trying to do with today's engineering students. And even more so, I think the students who are the employees who are successful over the long term have those broader views. If you talk to people who rise up as managers and eventually CEOs of companies, they are certainly those people who had the broad mindset coming in and recognized how the different parts of their organization work together and had the skills, communication skills, the appreciation for psychology and philosophy and ethics and economics and everything else that made them successful. So I think it's appreciated in industry, and I think it's also appreciated in research. Obviously, research wants a greater depth of knowledge, but if every one of my research students came in the door saying, how can I add value to this project, I'd be pretty happy with that. So I think there is a broad base of this that's valuable in whatever careers the students choose in their future.
I think one of the things I'm hearing several of you talk about is that, even around the breadth versus depth, it's more about the mindset really of saying, I'm not limited in my approach. I'm really trying to solve something. And if that means looking left, looking right, seeking help from this discipline or that, it's really adopting that mindset as much as it is about curriculum design or what you study. It's about sort of having this approach from the first day of saying, we're trying to solve something real. We're trying to solve something that requires inputs from a bunch of different things. And how do we make that happen? I think I'm being prompted to try and get this to closure. I think my sort of takeaway a little bit is that clearly this approach is something that is the need of the hour, whether you think about solving grand challenges, whether you think about the needs of industry and research. It's not trivial to solve it, as you're all saying. It will take a lot of work around design, around culture, around making the structures of the place, even thinking of infrastructure of how you build your physical spaces, as Dr. Desai was saying, to encourage interaction. And in some ways that makes it really fascinating for us at Plaksha, because that's sort of the journey ahead. the objective is clear, the task is difficult, and that should get all engineers excited. And that's sort of where we are. I want to thank the three of you for being here. This was fascinating. Thank you for your time.
Thank you.
And thanks for all the people that joined. I hope we gave you a little bit of a glimpse into this interesting future for engineering education, which is sort of more liberal in a sense in the way it interacts with different branches of it. Thanks, Arvind. Thanks, Keith. Thanks, Dr. Desai. Appreciate your time.
Thank you very much. Thanks, Niten.
Thank you.